Among the leading executives presenting at the automotive conference yesterday was Patrick Bastard, VP Advanced Electronics with Renault. He stated that the Renault-Nissan alliance will be announcing an electric vehicle for all strategy commencing in 2011. That means affordable models for all of us. Renault sees the EV as a potent contributor to meeting global CO2 emissions targets. Importantly, Bastard reported the limitations of lithium-ion batteries have now been overcome. EVs are becoming a viable mobility solution for the vast majority of urban populations. The challenge now is to develop the charging infrastructure for quick and standard charge options at home and at public charging stations. Navigation systems will include distances to the next charging station, and designers of smart grid and smart city systems will take into account the power demands and power storage potential of the electric vehicle. Meanwhile, the market predictions for the take-up of electric vehicles have been analyzed by market research company Strategy Analytics. We spoke to director Ian Riches, who was presenting at the conference. Your company is forecasting significant growth in the production of hybrid vehicles and explosive growth in the electric vehicles, short EV. Yet this is potentially misleading, as you admit, the figures derive from a very low base. So why is the electric vehicle market so important to the semiconductor sector?
You're right. The absolute numbers of electric vehicles will remain small for a good few years to come. However, the electronic content, the semiconductor content of each electric vehicle is significantly higher than for a conventional vehicle, particularly in the areas of the motor control and the control of the battery pack. So although overall we have small numbers of electric vehicles, we have many, many dollars of semiconductors in each of those vehicles. And thus it makes for an interesting market for semiconductor vendors, especially when you take the long-term potential of the market into account.
So what type of semiconductors are going to be most in demand, and for what applications?
Well, Strategy Analytics forecasts that by 2017 there will be around $1.5 billion worth of semiconductors going into hybrid and electric vehicles. And the vast majority of those, around 80%, will be power semiconductors, primarily IGBT type devices in detail. So that's really the main device type. The other types of devices, such as microcontrollers, will be a much smaller percentage of the market. So we're really talking about power semiconductors being the key device type.
So is this good news for all suppliers of these types of components?
Yes and no. The market is dominated by a few vehicle manufacturers. So in 2015, we estimate that 3 vehicle manufacturers, Toyota, Honda, and the Renault-Nissan group, will account for around 60% of the demand for semiconductors in hybrid and electric vehicle applications. So if you're doing business with these vehicle manufacturers or have hope of doing business with these vehicle manufacturers, then yes, it's potentially very good news. If they're not part of your traditional customer base, then you're going to struggle to find it so easy.
Thank you very much, Ian Riches.
Thank you.
And now, talking in more detail about the challenges and opportunities for the semiconductor sector, we have the Chief Executive Officer of Infineon, Peter Bauer. We have heard that the key drivers for innovation in automotive electronics are reducing emissions and lower power consumption. What new semiconductor device technologies are emerging from Infineon to meet these challenges?
There's a couple of semiconductor devices. Actually, the source of innovation in cars is really electronics. 90% of all the innovation comes through electronics and mainly through semiconductors. For example, the fuel consumption of cars can be reduced by 30% due to microcontroller components, but power components as well. And it ranges from highly complex, huge processors to very tiny voltage regulators, where you can basically reduce the power consumption by 60% by using a switched voltage regulator versus a linear voltage regulator. So the semiconductor components are the source of the energy efficiency of future cars.
Will these devices and technologies truly make a significant impact on emissions and power consumptions?
They will. We just take an example again, the engine, which consumes the most fuel and creates all the CO2. And if you take today's average in Europe, the CO2 emissions would be 180 somewhat grams per kilometer. European regulation asks for 120 by the year 2012. So you have to bring it significantly down. The technology possible today is that we can halve the fuel consumption within the next years. And how do you do that? Basically, with more processing power comes through semiconductors, with more power switching capability and better sensors. And again, power switching capability, you not only change the engine, you also electrify a lot of auxiliary components in the car, the water pump, the steering, the brake. By doing that, you manage them just by demand. They're not just kind of hooked up to the motor and consume power all the time. So definitely the impact comes through the semiconductors here.
A mega trend in automotive today is the electric vehicle, and electromobility is the new buzzword. But we hear that energy efficiency is the critical hurdle. So do semiconductors have a role to play in this area?
Well, that is relatively simple. The battery, as everybody knows, is quite expensive. But the battery is the source of all the energy in the car. So what do? You have to make the rest of the car as efficient as possible in order to get the most out of the battery, because this is the most expensive component in an electric car. And what helps you to do so are the semiconductors, because we can basically reduce the losses to drive the motor to a minimum. Our components allow, with very, very small switching losses, to drive an electric motor so that all the energy of the battery ends up in the electric motor. Only 5% of the energy is basically lost on the way there. So all other systems are much more inefficient. If you even talk about big electric generation with coal-fired power plants, you lose about 30% on the way. So here it's very, very efficient.
Thank you, Mr. Peter Bauer.
Pleasure. Thank you very much.
But that's all for now in a sunny Munich. At least the weather has encouraged the thousands of engineers and industry executives still flocking into Electronica 2010. In the next edition of Electronica TV, we will have a full report of the crowd-pulling CEO roundtable addressing the questions, what lessons have we learned from the crisis? And continuing the automotive theme, we take a closer look at electromobility, demonstrating that it is a broader concept than just the electric car.